disciplines. So everybody doing behavioral science, everyone doing language, linguistics, AI, organizational behavior, that would fit into our related disciplines. So the fundamental reason that universities and researchers come to us is that they're stuck. Their tools simply aren't good enough, which makes both research and teaching harder than it needs to be. Some are using tools that are simple, like survey tools. They're really simple, they're really easy to use, but they restrict the scope of their research. If you're a behavioral scientist, there's only so much you can do with self-reported behavior. And others who want to really get those strong behavioral measures are stuck coding. It's really powerful what you can do, but you're stuck coding, you're stuck in the lab, it's complex and time consuming, and this pulls focus away from the science, which you love. Either way, at some level, your research gets limited. What these researchers both need is something as powerful as coding, so up here in this box over here, but as easy to use as a survey tool. They want to break out of this deadlock. So whether you're leading research, teaching undergraduates, or managing a department, the ideal is the same. One platform that's powerful, accessible, and built for research. Researchers want powerful tools, built without coding, scale to thousands, run novel research. Educators want to give every student hands-on research experience without the coding barrier or lab scheduling nightmare. Departments want to manage everything from teaching practicals to participant studies on one secure, supported platform. And universities want to ensure data security, scalability, and value for money. And that's why LSE brought Gorilla in all those years ago. One tool for all your research needs. Where other tools have bolted on features, Gorilla was built from the ground up for behavioral science. It brings together reaction time tasks, surveys, games, simulations, all in one coherent workflow. Researchers save time, educators expand access, and departments simplify their budgets. It's more than convenience, it's scientific coherence. Gorilla often replaces a patchwork of tools within a single secure research-grade platform, purpose-built for behavioral science, yet as easy to use as a survey builder. In a nutshell, Gorilla helps you streamline your research, support your students, and use your scarce resources, in particular your time, more efficiently and effectively. So, what's our vision? Gorilla aims to create a better world based on evidence, not opinion, and we do this by creating an all-in-one research platform for human data collection so that you guys have the data on what works. In a nutshell, participants go in, here they come, and gorgeous cognitive and behavioral data comes out ready for your analysis. Inside Gorilla, you'll find a survey tool, a task builder tool, which does all of your classic reaction time and behavioral paradigms, and then also things like a game builder, a multiplayer tool, a shopping simulator, AI tools, UX, UI tools, social media simulations, and more. You'll see some of those later. I've got lots of great slides. I just want to show you some of the cool things. There's obviously a questionnaire builder. So our research questionnaire builder has all the functionality you'd expect. You can have any type of question, randomization by page, question and response options. We also support skip and conditional logic, as well as pipe text, as well as scoring, and much, much more. If you've been running surveys in Qualtrics, there's also a handy importer from Qualtrics over to Gorilla, so you can then combine your surveys with ease with behavioral measures. After our questionnaire builder, we have this task builder, which is where you'd create those classic cognitive and behavioral stimulus and response tasks that I'm sure you've covered in your textbooks. So what are we seeing here? This is a relational reasoning task. You could have anything involving reaction times, precision stimuli presentation, complex participant interactions and behavioral responses. You could have a Thatcher task, a flanker task, a go-no-go task, a Stroop task. All sorts of paradigms can be created with ease. And we're going to spend a fair amount of time. Oh, I should be clicking through it. There's the flanker task. Here's a maths question where you've got questions and answers, and you can give a countdown timer to create that little cognitive pressure if you wanted to. And here, I think, is a classic semantic priming task. It might be a mouse tracking task as well. I'm not entirely sure. Many, many more. In terms of advanced features, the task builder can also support eye tracking studies using the webcam. It can support mouse tracking studies using the mouse. This is a combination of the two, which we call mouse view. It's a way of doing mouse eye tracking without the eyes. You can do drawing tasks where you can have your participants draw whatever you want. It's been used for playing Pictionary, for language elicitation studies. Here, this is for an emotional study. You can build out social media simulations. The mental health impact of social media is hot in the press at the moment. So this is the type of tool you could use if you wanted to study that and make some causal claims. And we even support AI chat studies now as well. It's very easy to set up an AI chat study, see how AI impacts human cognition, attention, retention, memory, or learning very straightforwardly. And then we have some premium tools as well. We can support multiplayer studies for studies on trust, cooperation, or punishment, or to understand behavior in a social context. I know some researchers who use our multiplayer tool for studying language. Oftentimes language is studied in an isolated context, and yet when humans engage in language, it's nearly always in a social context. How about studying language in a social context? We have a game builder used for gamifying tasks. This is particularly useful when you're recruiting children who may struggle with our boring black and white tasks that we've traditionally used in psychology. We have a shopping simulation task, which is often used by epidemiologists and health psychologists to understand food and even alcohol or tobacco purchasing. It's also very used by marketing professionals to look at nudging as well. And then we have a UX UI tool for those interested in human-computer interactions. So that's a whistle-stop tour of some of the things that are possible in Gorilla, and we're going to go into each of those in more detail, but hopefully that gives you a little bit of an overview of all the things that are possible and how Gorilla allows you to go further than just a self-reported survey. Let's have a look at this case study. So this is an absolute classic use case for Gorilla. Here is Yui Lee. She's a PhD student in linguistics. In her view, separate survey and task. What's she studying? She's studying how does noun animacy affect sentence structure in English. So for her, the big research challenge was this need to combine questionnaire and speech production tasks, and she wanted to combine them. Unfortunately, oftentimes speech production tasks, which can be done in Gorilla and can be done online, have historically only been able to be done in the lab, which is slow and resource intensive. And then using separate surveys and task tools is inefficient and lowers the data quality. And obviously data quality is the key thing that we use. It's a key part of our science. So her solution was to bring in Gorilla. She could then have her speech production, comprehension, and psychometric tasks all in one tool, all without coding. And then she could deploy them online in one study for rapid data collection at scale and from much more diverse participants than if they had to come into the lab. Here's a second classic use of Gorilla in a more involved setting. So Jessica Massoni was at Birkbeck in the UK, and she was studying how does attentional control relate to children's sensitivity to classroom noise. Her research challenge is that we're really looking for very small reaction time effects when we're looking at attentional tasks. And so there's been a lot of difficulty linking lab style tasks to real world classroom outcomes unless you can collect data at scale in schools. Oftentimes, if you've just got one researcher having to go around lots and lots of different schools, that's a bit of an ask. So instead, she built something in Gorilla, which could then be deployed to lots of schools simultaneously. They could collect data from their children. She got quite a large sample of children, over 200, and they were quite young children doing an online flanker task, all with millisecond precision. She really appreciated that Gorilla was no code, very suitable for early career researchers. In particular, I mean, she's a PhD student, but one of the things that's been commented many times is it's brilliant for master students. You've only got a year if you're a master student. You don't have time to learn how to code in MATLAB from scratch. So having something that you can get up and running with in a day is ideal. With this project, the students were doing a lightly gamified version of the flanker task. It was gamified in order to ensure engagement from younger students. And I'll go and show you a little bit more about our gamification tools later on in this talk. The other thing worth noting, I'm not sure I said it out loud, was that Gorilla runs in the browser, so it's easy to access from your computer. All of you who are students, you can just go online, use it. You can collaborate together online with ease, but it also makes data collection so much easier from the classroom because you can distribute it to teachers to collect data on your behalf. And here's a third case study. This is Federica Rosante. Her research goal was, can social media use distort our perception of what we know? Her research challenge, similar to Yui's, was most tools are either too simplistic, they're survey only, or too technical and require coding or server setup. Additionally, in her view, existing experiments on social media bias are scarce and mostly correlational. So what she really wanted to do was to set up a properly randomized controlled trial so that she could make those causal inferences. So her solution was to use Gorilla's social media component. It creates this realistic and interactive feed with likes and comments and reposts. And then she could collect survey data and this behavioral data behaving with our social media simulation, all without learning to code. I rather love this quote from Federica. It took me half a morning to learn how to use Gorilla, and after that I was independent. It was priceless. As you can imagine, I've now heard hundreds of user success stories. The themes, though, are always the same. We've succeeded in making scientists' lives easier. We've succeeded in saving scientists a lot of time, and we've succeeded in enabling protocols that would otherwise have been impossible. This is some hard numbers from Jade. Jade told us that what had taken her 3 months before Gorilla, she managed to replicate in just a couple of days. If you imagine, if you're a PhD student, typically a PhD student involves 5 separate studies. If you have 5 studies and you can cut down the time from 3 months to 2 days on all 5 of them, that's going to save you more than a whole year. That's time that can be spent on your write-up and on having weekends, and we know how important weekends are for your PhD students. So, in essence, this is Gorilla's winning combination. It's really powerful. You can reach for so many different techniques and skills that your research isn't going to be limited. It's really easy to use. You're not going to get stuck bogged down in coding. You're going to save a lot of time. We've put a lot of work into making it easy to use. And it's really well supported. I've got Jack and Megan on the call, who are from our support team. You're never lost, you're never alone. If you do get stuck, you ping the support desk an email and you'll probably have an answer within 24 hours and most definitely within 48 hours. They do a really fantastic job of maintaining all of our educational resources and samples. We're all quantitative people, so I thought you might like a slide of Gorilla in the numbers. Gorilla's been used to test over 4 million participants. It's been cited in over 3,200 publications. It's used at over 1,000 universities globally. We've got 16 people in our team here. There are over 2,000 materials published to our open material repository, ready for you to clone and replicate, and over 300 experiments are launched each and every week. So there's lots of people using Gorilla in lots and lots of different ways. So that's the sort of like inspiration section of the talk, and we're going to come back to some more concrete examples later. But what I wanted to do now is just jump a little bit lower down into seeing Gorilla in action and getting started, so you have a really concrete idea of how to use the task builder. So the first thing with Gorilla that makes it different from a survey tool is that you can build surveys and tasks and games and multiplayer studies, right? So if you can build all these separate participant activities, you need a way to combine them together. And that's what this experiment flow tool is used. So when you get started with Gorilla, what you're going to start off doing first is creating your separate activities, whether they're a questionnaire or a task or a game. And then what you're going to do is link them together into this flow. And in this flow, we've got this experiment tree tool, which is for this flow, where you might first have a questionnaire, then you might randomize people to 2 versions of a task, and then you might bring them back to a final questionnaire, and then finally what you'll do is you'll set up your recruitment, whether you want to collect data online or from a cohort of your choice, or maybe using an online recruitment platform. And then you're going to watch the data roll in, you'll download it and analyze it. But that's the normal flow. Create your participant activities, create your study flow, then recruit your participants and watch the data come out the other side. Inside Gorilla, you're going to find a task builder. Now, about 90% of our users use the task builder, so and it's the bit that's different for most people. Everybody knows how to use a survey tool. They all work basically the same way. But a lot of people, if they're building behavioral tasks, are coming from a coding background. And so I want to go into a little bit more detail as to how we do this over at Gorilla. So our task builder is for designing any cognitive or behavioral task where you can have any stimulus or any response, and you can measure precise reaction times and measure accuracy. This is what it sort of looks like at a simplified level. You have a screen, you put your, like you would with Google Slides, you put the objects you want on the screen. This is our title text. Here we've got a yes button. Here we've got a no button. And here we're going to add an object. We're actually going to add a text box stimulus. Then once we've done that, the next thing we can do is we can link this stimulus to a spreadsheet. And that's really the magic. By linking it, we use this little binding icon to link it. We can create 4 separate trials just off the back of one screen, one layout, multiple trials. Now, by combining a limited subset of layouts and your key trial and your trial list spreadsheet, you can create your full task. So here we have an instruction screen, which was created like a Google slide. We have our trial, which is made up of a fixation and our stimulus response screen. That's the one we just saw on the previous page. And then we're going to create an end screen, which says, thank you for taking part. Put that together with our trial list spreadsheet, and we have our whole trial. In this way, it's as easy to create a participant activity, a reaction time task with just 5 trials as it is to create one with 100 trials. It's really very cool. Let's go and have a look at this in more detail. As you know, and you and I know, for great learning, after theory, we need to see some practical examples. So here we see a maths test, which interleaves simple maths with number knowledge. So here that was what's 360 divided by 4, or what's 3 plus 5. Here's our overall structure. We've got some instructions at the beginning. Then our key test phrase is fixation, and then this question that you can see here up on the screen. And then we've got a debrief screen at the end. Here's our spreadsheet where we've listed out all of our questions and our answer. And you can see that we're going first the instructions up here, then we're repeating the test 10 times, and then we've got our debrief screen down here at the beginning, at the bottom. And you can see how the GIF is running through all of these questions in turn. That's what's happening for the participant. Now, how is that all set up? Exactly as I showed you on the screen before. We've linked this. We've created this little area, which is where the question is displayed. We've called it maths question, and we've linked it over to this maths question column here. So that's how it knows what the content is. Let's have a look at another example. Here's our relational reasoning example. With a relational reasoning puzzle, you have an image and 4 image response buttons. The overall task has got instructions. We always need some instructions. Then our main trial is a fixation and our main trial screen. And then we have a finish screen with a little thank you message. Here's our spreadsheet. We repeat our trial 1, 2, 3, 4, 5, 6, 7 times, each time with different content for the puzzle image and for each of the response buttons. And we also have put in what the answer is, so Gorilla knows what the answer is. And here it is how we've created that one individual screen. Here's the puzzle, and it's linked through down to this puzzle question. In the same way, each of these response buttons will be linked through to one of these columns as well. And here's our flanker task. It's just a little bit more complicated because we've got more things changing on the screen, but it's basically the same idea. We've got an instruction screen. We've got our trial made up of a fixation and then the flanker screen. That's what we're seeing here. And then we've got our end screen. Here's our spreadsheet. We've got the target, which we've got 1, 2, 3, 4 left fish and 4 right fish. We've got some distractors, which are left or right. We've changed the fixation duration each time. And then, of course, we're randomizing the order of these trials so that it's not predictable to our participants. Each of the zones that are changing, so in this case, the distractor and the targets, will all be linked to an appropriate column here in the spreadsheet. Hopefully, this is starting to make a little sense at a high level. We're going to come back to this later, but I'm also delighted to take questions on this later, if at the end, if necessary. If you know you've got a question straight away, do please drop it in the chat now. Megan will make sure that I pick it up later. So let's go back to some more case studies, sort of interleaving the case studies with some theory, just to change it up a little bit so that it doesn't come as just one big barrage of information. I love this case study. This is Diana Laurillard. She's a professor of digital learning technologies at UCL's Department of Education. She's interested in building educational games that help children with dyscalculia overcome their difficulties by making it easier for them to develop a conceptual understanding of maths. With Gorilla Game Builder, she's created a constructionist game about early primary addition and number bonds. This gives students a lot of time building concrete understanding of number and getting precise feedback. And that's what you're seeing here. The students are given a target, and when they've mastered one target, they go up to the next target and the next target and the next target. And here they can cut things up, but they can also add them together. So they can slice and they can combine and recombine. So this gives the students a lot of time building a concrete understanding of number, getting precise feedback every single time. With a constructionist game, you're never wrong. You just might not yet be there. And you get to have a go again and again and again, every time getting accurate real-time feedback. What Diana then could do once she had her constructionist game online, she convinced the Singaporean government to use a countrywide RCT across primary schools in Singapore, having students play this game and seeing how it improved their understanding of number. So what could you do with these same tools in your hand? You might not be able to convince the Singaporean government to do something, but you might be able to do something else. So here is a speech reading game, also created in Gorilla Game Builder. This is designed to teach deaf children how to speech read. It was Professor Mairead McSweeney over at UCL who did this study. And she ran an RCT. She had a pre-test, which was a test of child speech reading, and a post-test, which was a test of child speech reading. With two different stimuli sets, both built in our task builder. And then she has a randomizer where she's randomizing participants between a control and treatment condition. In the control condition, they played a maths game. In the treatment condition, they were doing this speech reading game. So the person would say something, and when they got it wrong, the alien would vomit. And when they got it right, the alien would fart in a different array of rainbow colors, which if you are a 4 or 5-year-old is absolutely hilarious and keeps you playing the game. And you could build these things too. Here's another example from Dimitris Koutoukidis, who is a public health researcher and dietitian. So his research question was, can behavioral nudges in online supermarkets reduce saturated fat and calorie content in people's shopping baskets? His research challenge is that diet is a major determinant of health, but population diets remain suboptimal. Many food choices are automatic and respond to environmental cues, and testing interventions directly with retailers, with the supermarkets, is very difficult. As you can imagine, supermarkets are resistant. So researchers need a control way to test nudges before real-world implementation. The researchers then go and advocate to governments that they should turn these into regulatory policies, which then force the supermarkets to comply. So what Dimitri did is they built the simulated online supermarket experiment with like just about 20,000 products in this supermarket. And then participants are given a shopping list and they go and purchase items from typical UK food categories. And they tested lots of different interventions, healthier swaps, product order manipulations, both different messaging strategies, including calorie information and activity equivalent messaging. So that's super cool, the idea that you can build a whole shopping simulation and run a really large scale test to determine whether that would work rolled out to a supermarket. But what could you do if you had with the same tools in your hands? Here's an idea inspired by students at King's Business School that you could do with Shop Builder. This is their practical component of their Influencing Consumers course. Their teacher, Gillian, has created a control shop. This is the control shop down here, and this is what it looks like. It's got this blue livery, and it's got 21 products in it. All the participants in the study are told they are shopping for a 21st birthday gift from this shop. And in groups, the students are challenged to pick a product and nudge consumers towards the product of their choice. Let's have a look at just one treatment condition from one of the research groups. What they did first is they created a blog simulation. The blog first socialized the idea of buying a beauty product for a 21st birthday, and they also prioritized scented products as a perfect birthday gift. Then they had a social media feed. They built out a social media feed to activate sensory networks associated with their product of choice. And then finally, they put people into a shop, which they changed. They changed the livery to match their product of choice, which was this one, this Misty or perfume. And they added some labels to say that this one was selling fast, whereas other ones were down popped with saying clearance or men's health. Obviously, no real shop could implement these specific implementations, but the students enjoyed applying their theoretical knowledge and seeing the impact in the data. And what was extraordinary is these 3 steps together increased the sales compared to the control shop by 3 times. I think in the original shop, out of the some 500 participants, I can't remember the exact numbers, but yeah, there was a 3x multiple of how many people bought their product. One final example. I know many people are excited by behavioral AI research. This is the idea of experimental psychologists and behavioral scientists getting involved in the conversation about AI and understanding what it's like for a human to interact with AI and what impact this has on our attention, memory, learning, relationships. I have a whole webinar about using Gorilla for AI research. Megan, if you can share the link, that would be amazing if you haven't already. And if you're interested in this, I would highly recommend watching that webinar. I share a whole host of different examples that you can do. Today, I have time for just one quick example covering what's possible. In this example, we've programmed the LLM to do a personality assessment based on the Big 5. The LLM will ask a series of questions with follow-ups, with the aim of assessing openness, conscientiousness, extroversion, and agreeableness, and neuroticism, the five parts of the ocean of the Big 5 personality assessment. Scoring these open text responses would manually is usually time consuming and costly, but it's really straightforward because we can do it in the background with an LLM against a rubric of our choice. And for some of you who are interested in qualitative research, you can take this to a very different example as well. You could run any sort of qualitative interview and score answers against a rubric of your choice. It's really very cool. So this is how this is set up. Here we've got our GIF. So you can see what's happening in terms of the participant experience. That's what you were just watching. Here's how the screen's set up. This is how we usually show it. And here's our spreadsheet down here. So the LLM starts by asking the question in this row of our spreadsheet. So it says here, when you're in a group setting, work, social, or school, how do you usually end up participating in the conversation? So that's the initial prompt. And then we've also given the AI an aim. So it said, ask follow-up questions, but this is what your aim is. Your aim is to listen for outgoing, energetic, and participatory. The participant is in a group situation. Attend to whether they initiate conversations, gain or lose energy in social situations. Signals may include talkativeness, energy gain from interaction, initiation versus response, enthusiasm. So we're instructing the LLM how to follow up so it's zeroing in on the right answer. And then we've given it a scoring prompt as well. We've told it how to score the answers as an extroversion on a 7-point scale from 1, strongly described as being quiet or withdrawn, all the way up to 7, highly outgoing, thrives on group interaction, dominant speaker. Oh, there's the aim bit, sorry. And then finally, and here's the score bit. And these are all linked here, but mostly it's driven by the spreadsheet. So what could you do? What could you investigate? Here's just one example. You could test how people respond to different AI tones and how that impacts emotional connections with an AI. In Gorilla, we design, you're probably becoming familiar with this experiment tree view now. In Gorilla, we designed the overall study flow in our experiment tree. And once you have your tasks, so you could have your main task, you could create 3 different variants of it with 3 different personalities by feeding it 3 different spreadsheets. Here we've got everyone's favorite over-enthusiastic friend who's extremely excited, warm and chatty and highly supportive. You could have your encouraging teacher or coach who is supportive and clear and motivating. I don't know why he's American, and patient instruction. And then you could have your positive but stern parent who's warm, caring, positive and gently guiding or reassuring. And then over time, you could have those personalities change over time. I've got them so that each one becomes impatient over time. And the dependent measures could be when somebody ends the chat because they're no longer enjoying it, or if you had a pre-test and a post-test, you could have an anxiety or a mood test before and after, and you could look at the impact of these different personalities and how they deteriorate over time. Maybe it's easier to tolerate a positive but stern parent getting impatient with you than your over-enthusiastic friend becoming impatient with you. This is just an example which I've sort of come up with. I've kept it sort of fanciful to make it really concrete, but you could design anything you want here. Next steps. So in this final section, I want you to start imagining what study you could build with Gorilla. If you're a perception researcher, how could easy access to larger samples or even niche samples, that's one of the benefits of going online. You can go and reach a very specific niche population, impact your research. What could you do if you could combine your research with other tasks, questionnaires, or gamified perceptual tasks? What could you discover with fully engaged participants generating rich data at scale? And I've just shown some of the perceptual research, the classic perceptual research tasks that we have built in Gorilla, just as a sort of imagination prompts for you. If you're a language researcher, what could you do if you could take these traditional lab-based tasks online and collect data at scale? What research questions would you be able to answer if you could reach bilingual populations as easily as monolingual populations? What if you could reach specific language groups or those with specific language impairments? If you're an executive function researcher, what could you research if you can combine traditional executive function tasks with more real-world executive control environments, like shopping or being on social media? Ooh. Did I go through all of those? They just don't seem to have animated in. No worries. Then we've got a congruency one, an inhibition one, cognitive control there, and then an abstract reasoning one here. How might you study executive function with multitasking in a social setting or under real-time pressure? Imagining studying executive function in more real-world contexts rather than isolated tasks at scale. And if you're a memory researcher, imagine moving beyond abstract word lists to study memory in applied real-world context. What could you discover by combining traditional lab-based memory tasks with controlled shopping simulations, for instance, that require memory resources, or UI ones where you need to work out how to navigate a website? Can we improve our theoretical models by better understanding memory in a more ecologically valid context? And again, I've given you some examples of classic tasks that we have built into Gorilla, just so you can see the wide variety of tasks that are supported, all without coding. There you go. Right. One final little nudge towards the experiment tree. I hope you're seeing that the experiment tree unlocks new research paradigms because it allows you to combine surveys and tasks with other experiences like games or shopping simulations. It's far easier to use than people expect. To illustrate, here's our classic randomized controlled trial setup. Participants are starting with a consent and then demographics forms. Then we've got a pre-test and a post-test, which are counterbalanced. They're exactly the same test, maybe with two different stimuli sets, which we've built in. And then we have a randomizer here, and we're moving people towards control and a treatment condition. Again, these will be exactly the same task other than one variable that will have changed. So you can see in Gorilla, creating a randomized control trial could be as simple as creating 2 questionnaires, 2 tasks, and then changing some of the variables. In other tools, this can require several separate studies and extensive scripting. In Gorilla, it's a single, well-structured, easy to understand tree. It takes minutes to build this, and then you can put it online and collect data at scale. How to get started? Well, you've done a really great job of getting started today by coming here and listening to this talk, so you have a really clear idea of what's possible with Gorilla. Quick and easy to get started, allowing you to go from signing up to building your first task in just a few minutes. So if you're feeling ready, here's what to do next. Go and sign up. This is where you'd go and sign up. Watch our Getting Started webinar. The Getting Started webinar has remember there were like 4 slides in the middle where I showed you how sort of the guts of using Gorilla, and it sort of expands on that content. Then create a project, create your first task, add your collaborators. As I said, Gorilla is all online. It's really easy to add collaborators. Some of you will be working with other students in groups, and you can all build out bits of your study together. If you do get stuck at any point, just message our support team. Megan and Jack will no doubt are on hand to help you. They're really, really friendly. They're both experimental psychologists by background, so they really do know what they're talking about, although they won't know your niche area of research. Good luck. Can't wait to see what you build. Happy experimenting. And then this is where we're going to stop for now. Megan, you can press stop on the recording, and I'd be delighted to take any questions.